Hi, my name is Ben Hawkinson. Today I'm going to talk about my first lab project, IO-Link. In this project, I built a trainer to show off IO-Link devices and their capabilities. In this project, the IO-Link hardware I got was two laser distance sensors, ultrasonic sensor, RFID read-write head, along with a stack light and a programmable bulb, all of which I connected to the IO-Link compact multi-protocol I/O module for Ethernet. Using this hardware, my initial goal was to use the laser distance sensors to find the location of whatever object I put on the conveyor belt. Later on, I added the chips that you see on top of the objects and the RFID head to read and write to those chips. Along with the IO-Link, I also had a Turk BL20 GWEN remote rack with an 8 DIP 24 BCD DIA input module and a DOP 24 BCD 0.5 amp DIA output module for digital inputs and outputs for my project. I use my input module to read the condition of my e-stop and start-stop buttons, and I use my output module to command the direction I wanted the conveyor to move and when I wanted to run. This is my HMI. Currently I'm logged in as an admin, so we can see dev mode and everything. Here we have basic overview of what the conveyor belt is doing. You can see the direction it's moving, the delay time, and also we have start-stop buttons and two circles, outer circles, whether or not there's been a fault or an e-stop condition, and inner circles whether or not the system enabled it has been triggered. So if it's stop, it goes red, conveyor belt stops, it goes green again. This sits here and will slowly time on. And then if we have faults around this, other circles will appear based off the fault, give you a hint to what might have been causing it. Coming here to conveyor belt, you tell it to change direction, so running left, hit the button, and now it's running right, change it back. And then we got 4 inputs coming in. We got 2 laser distance sensors, 1 ultrasonic, 1 RFID, and then here's the reading that both these sensors are giving me. Light green is where the object can be. The dark area is where the sensor can't, well, the object can't be because it's looking through that. And this is on the right side, the big one. This is the left side, smaller one. So currently it's all the way to the left, and that's heading back towards the right. And then we got this the RFID head. So we got how many times each chip's come by, the 5 integers that we can write to the chip, color of the chip, and then commands that we give it. So we can change the value or hit 0, but we actually didn't just 0 there until we hit right. So we put it now. If I hit 0, read, it's going to be the last time I wrote it. Send it off. If I do this, next time the chip comes in, it's not actually going to change the value up here. So you can set up your recipe or whatever information you want to write on the chip Then when the chip comes, you can write to it and then send it on its way. And then that's what, and then the chip comes back, we'll see the value that's been written on the chip, along with, if you don't want the chip to stop and just want it to keep going, but keep the value, you can, instead of auto zeroing it, you can keep it manual 0. So when the chip comes back by, you'll catch the value real quick, but the conveyor belt will never stop. Along with, you auto write every time the chip comes by, it's gonna quickly sense the chip there and then immediately write whatever true values are up here to that chip. So if we continue, go down to tower, we got our stack lights on top, we got our programmable bulb. These are the values I'm sending in. I turn it off, turn it back on, in disco mode, so if a chip comes underneath, it'll really quickly send some preset values that cause the lights to dance around. Go down here, dev mode. In dev mode, we got a few things. We got our horn for e-stop, so if someone triggers the e-stop, the horn's gonna go off. This is our empty belt conveyor, so if an object isn't on the conveyor belt. This is heartbeat to the remote rack, so if there's no heartbeat coming from the remote rack. This is the flashing lights on the stack light. You can change the speed of them. You can change the delay for running right and left. You can also change the watchdog for the conveyor belt just running in general. Things that went well, went wrong, what I can improve on in conclusion. Things that went wrong for me were time management, priority management, staying up on paperwork. For my time management part, I thought I was doing really good until about 5 weeks ago. I mapped out what I had left to get done and realized how much there was left and how far I was behind where I should have been. And with that, I wish I had better priority management, making a better list of top priority, low priority, top priority being things that need to get done, low priority being things that would have been nice to get done but not required, to make up for my lack of great time management skills. And with paperwork, I wasn't always staying on top of it, which led to me falling behind eventually. And when I fell behind, it was really hard for me to catch up because I always felt like there's other work that I need to get done instead of doing the paperwork, which just seems simple and boring, which led to me later on finding work that would have been a lot easier to get done if I had the paperwork done, and I was really upset with that. Things that went well: connecting my IO link over Ethernet, connecting my start, stop, and e-stop buttons to my remote Turk rack, setting up laser distance sensors to the IO link module, and making AOI my PLC for my stack light. I feel like all these I did really well on. What can I improve? Main thing I should improve is my time management and pre-planning. So planning out what I need to get done, and then as I'm going through with it, be adjusting my goal, because I made a goal, then got to that goal, and I realized how far that goal was off from where I really should have been, and I would have to adjust it, and I was always catch up. So it's like a PID loop, but I wasn't taking the feedback in as quickly as I should have been. And in conclusion, even though at the end of the day I'm sad to say I didn't have more time to improve my system, I feel I've learned a lot from this project and common pitfalls that I might find, and hopefully I've will not do those same mistakes again, and next time make new mistakes to learn from.